All right, coming back, before I leave this page and go on to another shortcut rule that we're going to look at, I do want to kind of point something out to you, and this goes back to the idea of differentiability. Now, we pretty much knew that anytime you have a power of 1/3, that there is a vertical tangent at x equal to 0 in this case. So we learned in the last section that it's not differentiable at x equal to 0 because of that vertical tangent line. Notice that the nice thing, especially when we start getting into these shortcut rules, take a look at your derivative formula. Your derivative formula is undefined at x equal to 0, exactly where it was not differentiable, and that will always be true. If you are using a formula in a shortcut rule and you are calculating your derivative, the derivative formula, the domain of the derivative formula, these domain restrictions will exactly be the same as the places where the g of x was not differentiable for one reason or another. It will come out. Like for example, we take a look here at C, kind of the same idea. We know that this is not differentiable at x equal to 0 because at x equal to 0, we know that we have a division by 0 problem, okay? And then if you take a look at this, and I didn't rewrite this at the time, but if I do go ahead and rewrite this at the time, you'll see that this right here is actually a negative number, right? Because negative pi minus 1. So this x is really in the bottom. We could rewrite this as negative 5 pi over 3 x to the pi plus 1. So we also have a division by 0 problem here as well. And so that's also going to tell us that it is not defined, that if I were to take the derivative and I would try to plug 0 into the derivative, it would be undefined, which is also telling me it's not differentiable at x equal to 0 for this function. So you'll see that it definitely kind of works out. Same thing's true here. This is a division by 0 problem. It's not differentiable at x equal to 0 because you have a discontinuity, a non-removable discontinuity. And when you get to your derivative rule, notice that this derivative is undefined at x equal to 0. And the derivative being undefined means that it's not, the function, the original function was not differentiable. So I thought I would mention that kind of while I was here. All right. So let's do another few examples of this. I kind of stopped it at the last time because it took a little while to prove the power rule, but now that we have it, I want to find the slope on the graph when you have x equals negative 1, 0, and 1. So I'm looking for the slope of the tangent line, also known as instantaneous rate of change. So now what we've done is we basically have created a way where we can come up with a shortcut. You can think of this, remember, simplify early and often, 1/2 x to the 4th. So the derivative, according to my shortcut rule, would be 1/2 times 4, 2, x to the 4 minus 1, 3. And once I very quickly get a derivative rule, then the slope at negative 1, plug and chug, negative 2. The slope at 0 is 0. The slope at 1 is 2. So very quickly we can come up with these slopes, and it is a definite time saver over the limiting process that we were doing in the previous section. All right, let's find the equation of a tangent line and the normal line to 3x squared, nice little power rule, when x equals negative 2. All right, so let's start with the tangent line. Remember, to find the tangent line equation, you need two things. You need a point and you need a slope. So the point, we pretty much can take our negative 2 and then plug negative 2 into our function and figure out our values. 4 times 3 will give us 12. Our slope, we find the slope of the tangent line by doing the derivative at negative 2. Now that's going to require a little bit more work. So let's come over here and do the work. We're like, hey, less work than it used to because I can use the shortcut rule. The derivative at any point x, multiply 6x, subtract 1 to the first. So f prime of negative 2 is going to give me negative 12. And as soon as you have a point in the slope, you can write your equation of the tangent line. Y equals your slope, negative 12, x plus 2 plus your y value, 12. And then we're done. See how much faster the problems are once we start getting in these shortcut rules. Okay. So everybody's okay with that. Let's take a look at B. B is now asking for the equation of the normal line. Remember that a normal line is where we have a slope that is perpendicular to the tangent line slope. It's still going to go through the same point, negative 212, except now my slope is going to be the perpendicular slope, opposite reciprocal of the derivative at negative 2. So this is going to be negative 1 over negative 12, or 1/12. And again, once we have our point and our slope, we can write our equation, our 1/12 x plus 2 plus 12. So very nice and easy, very quickly, as long as we kind of know our relationships that we're going to be looking for. All right, and then now let's take a look kind of at the picture of this to kind of see what we have. We have 3x squared, which is nothing more than a basic parabola with a vertical stretch. Okay? So we have our parabola with our vertical stretch going in, so I'll make it a little bit taller than it normally is. And we're looking at negative 2, so our negative 212, let's say that's about here. And so we had a tangent line, so let's draw in our tangent line. I like to make the tangent line red. So we'll draw the tangent line in, so it looks like that. And then we'll draw in our normal line, we'll do that one in green, which is the perpendicular. And so in part C, what they're basically asking you is to find the other intersection point where the normal line intersects. So I want to know, what is that point right there? Well, to find the intersection, I take the parabola, which was y equals 3x squared, and I take the equation of the normal line, y equals 1/12 x plus 2 plus 12, and to find the intersection, you just simply set them equal to each other. So the work for this, we would say 3x squared equals 1/12 x plus 2 plus 12. Little trick, we can multiply by 12 to get rid of the fraction, so we don't have to worry about it. So 12 times 3, 36 x squared equals x plus 2 plus 12 times, I almost made a mistake right there. I multiplied both sides by 12. 12 times 12 is 144. Collect like terms, get everything on one side. 36x squared minus x minus 146 is equal to 0. This actually does factor. I'll let you play around with it, but it factors to x plus 2, and then 36x minus 73, and you can double check that. 36x squared, 2 times 36 is 72 minus 73, there you go, and then my 2 times that. And so we get x equals negative 2, which we kind of already knew, right? Because the one intersection point was at the negative 2 for the x value. So the other one is going to be x equals whatever 73 over 36 is. And since they asked us for the other point, I need to actually take my 73 over 36 and then calculate f of 73 over 36, which I don't know if we have to get that exactly. Let's just pull out our calculator and figure out what that is. Not a nice number, but it ends up being 5,329 over 432. Okay, sorry, I couldn't pick the nicer number, but just making up the problem. So you can see the idea is that you kind of just methodically go through tangent line equation, need a point and a slope, use the derivative. Normal line equation, same point, opposite reciprocal for your slope. And then finding the other point where the normal line intersects the curve, we'll just set them equal to each other and do a little algebra. And they do like to, in the AP, to have you do a little extra beyond just finding the equations of the lines. All right, let's find the coordinates where this function has tangent lines with the following slopes. So again, this idea is I want the slope to be -3, so I'm going to find a formula for the slope. So I'll just do that up here. F prime of x would be -10x. And then I pretty much just solve equations. I want to know when is the slope. F prime of x, m is another name for f prime of x, which means -10x equals -3, x equals 3/10, and we're done. So, oh, and it says find the coordinates, so then of course I'd have to go, well, 3/10 is the x coordinate, and then I have to do f of 3/10 for the y coordinate. So we end up with 9 over 100 times 5, that's 9, -9 over 20 as our y value. So just make sure you answer the question that they have asked you. Slope is 0, f prime of x equal to 0, -10x equals 0, and x equals 0. And again, the coordinates of where that happens would be 0, and plugging that in, f of 0 is 0. And then our last one, your derivative is equal to 2/3. So -10x equals 2/3. X equals 2 over -30 or -1/15. So my point would be -1/15 f of -1/15, which would be, I use my calculator for that, 1 divided by 15, square it, and then times -5, -1 over 45. So you can start to see where we have lots of examples that we're working on that we can use this kind of shortcut rule. Now, of course, the important thing with the power rule is that rewriting is very important. You have to have it in the correct form. It has to be in the form f of x equals a constant times x to a power. And n, of course, must be a real number in order for this to work. So when you see things like this, remember this is the verb, and we take the derivative of what's inside with respect to x, the very first thing that you should do is rewrite it into the correct form. So this would be the same as 5/2 x to the negative square root of 2. Once you rewrite it into the correct form, then you just simply take the derivative, -5 square root of 2 over 2, x negative square root of 2 minus 1. Okay? Same thing here. I'm going to rewrite this one. Now notice that over here, the 2 has nothing to do with this power because there are no parentheses. Here I have parentheses. So when I go to rewrite this, I bring the verb down because I'm just rewriting. I haven't performed the action of the derivative yet. That this 2, really the first thing I should do is probably distribute. 2 cubed is 8x cubed. And then I should simplify early, simplify often. This ends up being 1/2, 4 over 8, x to the -3. Now I have it in the form that I need to take the derivative. Now I performed the verb, take the derivative of this, you multiply, and be careful, subtract 1 from a negative number would give you -4. Right? Same thing true over here. This one you got to do a little remembering of your exponent rules. So I'm taking the derivative with respect to t, which is good because that's my variable there. This is the same as 7t to the first, and then 3t to the 1/2. So I think of that first, and then I remember that when I have the same base and I'm dividing, I should subtract my exponents. So this would be 7/3 t to the 1 minus 1/2, or 1/2. And now I can perform the verb, take the derivative, 1/2 times 7/3, 7/6, t, 1/2 minus 1, -1/2. Same thing is true here. Again, be very, very careful about what you're doing when you're rewriting. You have to know your algebra rules when you're doing it. I'm taking the derivative with respect to m. I'm going to move all of this up. Let's do this in a different order this time. 3m squared. So I move it up first. Now I'm going to distribute. square the 3, 9. 9 times 6 is 54. M squared. And now I can take the derivative, use the verb, 2 times 54, 108 M. So rewrite early and rewrite often.